All right, so we'll move on to logarithmic functions, and remember that log of x means log base 10 of x, and ln x equals log base e of x. We also need to remember how to evaluate a logarithm, and just think of this sentence. To what power do you raise 2 to get 8? And we all know that is 3. But if we say, to what power do you raise? If we think about that, when we read this, and then the 2 goes there, to get 8. To what power do you raise 2 to get 8? We know that's 3. So let's see how to evaluate these. Here, if we have 512 and we can't tell what power, we have to think of what power this is going to be of 8. And it turns out it's the third power. And if you write it like that, then you have, to what power do you raise 8 to get 8 to the third power? You raise 8 to the third power. The answer is 3. To what power do you raise 4 to get 4 to the 3.2? You raise it to the 3.2 power. Before we do this one, let's rewrite that. It'll be 2 to the negative 5th. The negative does the reciprocal, and then 2 to the 5th is 32. To what power do you raise 2 to get 2 to the negative 5th? And here we need to think of how can we write this in terms of 16. So one way to do it would be 2 is the fourth root of 16 to the 1/2. This is 2, and then the 1/2 is the radical. And then we can say that's 16 to the 1/4 to the 1/2. So now it's 16 to the 1/8. To what power do you raise 16 to get 16 to the 1/8? You raise it to the 1/8 power. All right, pause and try those. Three to the fourth is 81, so then we can find the power. 7 to the negative 1 is 1 over 7. 7 to the negative 2 is 1 over 49 because we're going to square. And the radical is a 1/2 power. So if it just said to graph, then we can graph it in whatever way we want. But if it says the palette, if I say use a palette, then it means put down as much information as you can, and we follow this format. We'll come down here and talk about increasing, decreasing, and end behavior. So that'll be later. And let's take a look at this. The y-intercept is when the x equals 0. And this is saying, to what power do you raise 1/5 to get 0? If we raise 1/5 to a negative number, then we're going to get a reciprocal, but not 0. And we can't raise it to a positive number. If we raise 1/5 to the 0, we just get 1. So this is undefined. So there's no y-intercept. X-intercept, you make the y 0. To what power do you raise? 0 is going to be the power of 1/5, and we just go like this. Whatever the base is, then we make that the base of each side. So now this is the exponent of 1/5. 0 is the exponent of 1/5. 1/5 to the 0 is 1. And then we have to do this. This all cancels and we get x. But I don't want you to think that we just cancel, like draw a line like it's division. This is not division. This is saying here is an exponent of 1/5. We don't know what this is. But whatever number it is, when we raise 1/5 to that power, the answer is x. 1/5 to that power is x. Let's wait until we do the graph for the asymptote. So right now we have an x-intercept of 1. And let's look at some good choices for x. So we have log base 1/5. So let's try 5. Log base 1/5 of 5. To what power do we raise 1/5 to get 5? That's -1. So let's try 1/5. To what power do we raise 1/5 to get 1/5? 1. We could even go to 1/25. To what power do we raise 1/5 to get 1/25? That'll be a 2. So at 5, we'll go to -1. At 1/5, we go to 1, and then it goes up to 2. We see the graph going like that. Then it's easy to see the asymptote is x equals 0, a vertical line at x equals 0. The asymptote is there. Domain. These x values don't have a y value on the graph. The x values start after 0, and now we have all these y values. So the domain starts at 0, goes to infinity, but you don't include 0. The range. This keeps going down. So we have -infinity to +infinity for the range. Where is the graph increasing? Well, here, don't read this arrow as increasing. We have to read the graph as decreasing. Follow it from left to right and as decreasing. So this is never increasing. and is decreasing from 0 to infinity. What's the end behavior at the right as x goes to infinity? The end behavior is the y value is going to negative infinity. And then this is undefined as we go to x, so we'll say it does not exist. Okay, do the same thing for this. Pause and try it on your own. Okay, so the y-intercept is when x equals 0, and that's undefined. No y-intercept. The x-intercept is when the y-intercept is when x equals 0. The x-intercept is when y equals 0. So we want to make 4 the base of each side. This is the exponent of 4. 4 to the 0 is 1. 4 to the log base 4 of x is x. So we get x equals 1 for the x-intercept. And let's choose make some good choices for x. If it's log base 4, we already have x equals 1. So let's try a 4, 1/4, and that should be enough. Log base 4 of 4. To what power do we raise 4 to get 4? To what power do we raise 4 to get 1/4? -1. So we'll go at 4, go to 1. Add 1/4, we go to -1. And then we can see the shape. Vertical asymptote is at x equals 1. And the domain starts at 0 and goes to infinity. Don't include 0 because that's the asymptote. And range is all real numbers. It goes down to negative infinity and it goes up to positive infinity. Where is it increasing? We read it from left to right. It's increasing from 0 to infinity. And it's decreasing, never. Remember that this infinity for increasing is not referring to the y. It's not referring to going up. It's referring to this infinity out here. X is going to infinity, and it's increasing along that interval. End behavior at infinity. What is the y value doing? The y value is going to infinity. And then as we go to the left, there's no limit to the left. All right, let's graph let's look at some shortcuts so we don't have to do the whole palette. We can just use transformations. So let's graph all right, and here's where some students get confused. They read this and they think it means this. So make sure you pay attention to parentheses, or if there are no parentheses. If there are no parentheses given, you can't just put them around this. You could put them around that, and that helps you see that that is outside of dx. For both of these, let's talk about the parent function. And let's choose 1/3, 1, and 3. To what power do we raise 3 to get 1/3? -1. To what power do we raise 3 to get 1? 0. To what power do we raise 3 to get 3 is 1. So we can use these parent function coordinates to help us graph. And then we have to identify this 2. Inside changes. If it's inside with the x, it's a horizontal change. If it's outside of the x, it's a vertical change. When it's inside, we do the inverse of what's given. When it's outside, we don't do the inverse. If we're going to have a horizontal change, we change the x value of each coordinate. And if it's an outside change, we change the y value of each coordinate. So let's look at this. And we'll write down the coordinates of the parent function. This is log base 3 of x. And then we'll do log base 3 x minus 2. And this says add 2 to each x value. One-third plus 2, 1 plus 2, 3 plus 2. And now we have the points of the transformed function. Let's look at the parent function. At 1/3 we go to 1, -1, and at 3 we go to 1. There's the parent function. And now we'll go 2 and 1/3, -1. 2 and 1/3 is -1. 3, 0. And then we'll go to 5. 1, 2, 3, 4, 5. Up 1. The asymptote will help us graph. And we saw that we had a shift to the right. So we see the asymptote shifting to the right. All right. And pause and try this one. And this is an outside change. It's changing the y. We don't do the inverse. So we're going to go -1 minus 2, 0 minus 2, 2, 1 minus 2. We have the parent function. And now we have the transformed function. At 1/3 we're going to go down to -3. And then we'll go at 1, go to -2. At 3 we go to -1. With a vertical shift, vertical translation, we don't have to change the asymptote. All right, pause and try those. And if we had to put in parentheses, it would just go around the x. So we know that the -1 is outside. That means it's vertical. We're going to multiply the y values by -1. So -1 times -1, 0 times -1, 1 times -1. Parent function. And then we'll go 1/3. Now we go up 1, 1, 0, and then 3, -1. The vertical asymptote stays in the same place. And there's a vertical reflection. Here we have a negative inside with the x. That means it's a horizontal change, and we're going to, in this case, it doesn't matter if we divide or multiply, but we do the inverse. So let's just say we're going to divide by -1. Divide the x's by -1. Divide the x by -1. Divide the x by -1. Divide the x by -1. Here is the parent function. And then we'll go -1/3 down 1, -1, 0, and -3, 1. So now that creates a horizontal reflection. There's the horizontal reflection, and it's reflected into the y-axis. Okay, pause and try that one. No, sorry, log base 3. So 4 is outside. If we put parentheses, that's where they would go. So 4 is outside, that's vertical, and we multiply the y values by 4. There's the parent function. And then we're going to go at 1/3, we'll go to -4. 1/3, we go down to -4. At 1, we're still at the same place, 0. And then at 3, we're going to go to 4. All right, we're going to graph that. That's log base 10. Pause and try to do it on your own. To what power do you raise 10 to get 1? You raise it to the 0 power. To what power do you raise 10 to get 10? It equals 1. Now we have points on the parent function, and then we can change the x and the y. All right, let's do any multiplication before we do the addition. This is an outside change, and that means it's changing the y value. So we're going to go negative 2 times negative 1, negative 2 times 0, negative 2 times 1. And then we'll do negative 2 log base 10 of x plus 5. So plus 5 is also outside, and that's vertical. We're going to add 5 to the y value. The parent function is 1/10, negative 1, 1, 0, and 10, 1. So we know the parent function is like that. Then we're going to graph this at 1/10. We'll go to 7. At 1, go to 5. And at 10, we'll go to 3. Make sure I made it kind of look asymptotic, but this is not asymptotic. It keeps going down. There's no horizontal asymptote. It's only a vertical asymptote. Okay, and we'll do this one together. So here's some choices that make it easy to evaluate. Ln of 1 over e is the same as ln of e to the negative 1, which equals negative 1. Remember that ln of x is log base e of x. So that's how we're getting negative 1. Ln of 1, to what power do you raise e to get 1? You raise it to the 0. To what power do you raise e to get e? You raise it to the 1. And we have points for the parent function. And then we can look at the transformation. Ln x and then we're going to do, we have an outside and an inside. Let's just be safe. We're going to do the multiplication first. Multiply the y value by 3. And then we're going to do the inside. The inside change is the horizontal change. It's going to do the inverse of addition to the x value. So let's subtract 2 from the x values, and we get about negative 1.6 if we go 1 over e minus 2. And then we'll do 1 minus 2. E minus 2, that's 2.7 approximately, so that'll be approximately 0.7. And when we graph that, natural log, the parent function, at 1 we go to 0, at 2.7 we go to 1, at 1 over e, which is near 1/3, we go to negative 1. So we can see the parent function. And then we'll graph this at negative 1.6. We'll go to negative 3, negative 1.6, down 3. And then we'll go negative 1, 0, negative 1, 0, and 0.7 up 3. This was a horizontal shift left 2. The parent function has an asymptote here, so the new asymptote is going to be at negative 2, and that helps us draw more accurately. Okay, stop there.